So here we are at 12C, which is another intermediate video. And right now I thought I'd have this opportunity. I have the sun right on my west. So I've got this just setting sun exactly on a west vector, hitting my north-south direction on my pendulum, which is one of these rare opportunities which only happens here in the summertime. Okay, what I'm trying to do is just to see if that affects the pendulum in any way. Perhaps it doesn't, but there could be some ether, electromagnetic effect, who knows, but good opportunity to catch. Also, I want to revisit this launch indicator. I've actually put a little bit of tension in the cable, so hopefully our launch indicator will spin around a bit, and if it doesn't affect the pendulum in any way, and we still get a straight swing, I think we could nearly write off this indicator. I'm just a little bit curious about it, what its effect is, because no one else has it marked, so maybe it doesn't make any difference. The CV joint, let's address that later on. I'm not happy with the pendulum. Foucault's design with no constant velocity joint in your system, but maybe it doesn't matter. Also, definitely want to confirm this 7:1 ratio. So, Foucault pendulum is 7:1 ratio. So let's go back to his 7:1. Let's make all our experiments in the 7:1 ratio. I think that's where it's very stable. So let's prove that the pendulum is stable in that 7:1. So to do that, I've just added a little bit to my pendulum. I've added another 40 millimeters to give it a little bit more boost. Also, what we'll do is we'll do a really large swing. We'll do it, see if we can get to 800 on our swing. So we're going to come right out here with our swing. And I believe that the pendulum outside that 7:1 ratio will become unstable. It could go clockwise or anti-clockwise. Who knows? So let's give that a try. Alright, so let's do our experiment and let's get into it. Okay, quickly looking at the sunset, leaving me here at about 19:20. Just out of my lab window. The time is 19:15 on the 4th of the 1st, 2025. So the sun is just going down on my west. I have a perfect west sunset. And here we are with our standard pendulum setup, our illuminated string or suspension cord, all the way to our magnetic decoupling or coupling system up the top. The only thing I've changed is I've increased the swing distance by 20 mils either side of the existing marks, and I've added a new detent mark here to indicate my swing distance. I just go a little bit more amplitude. Everything's the same. Alright, now I'll switch the camera on. Alright, recording. And now I'll just remove that. Here we go. I'll just remove that other laser light. I think that was confusing. That other laser is confusing. Yep, here we go. For our next launch. Perfect sunset launch. Okay, that pendulum swung around. It swung right around and come back again. Do not like that. Anyway. Alright, recording. And now I'll just remove that. Here we go. I'll just remove that other laser light. I think that was confusing. That other laser is confusing. Yep, here we go. For our next launch. Perfect sunset launch. Okay, that pendulum swung around. It swung right around and come back again. Do not like that. Anyway, here we go. Do not like that swing around of our launch index indicator. Not happy. However, we seem to be settled down to an even swing left and right. As you know, I do not like that launch indicator swinging because I'm very sensitive to that, because I'm the only one who actually marks it. And I believe that it's got something to do with this pendulum. They're hiding from us, but at this stage I'm not quite sure what they're doing with it. Alright, we've got even swings at this stage, either side of that black line. 19:17 is our time. And this is video 12C, just to give you that sunset condition. Still equidistance. Alright, we're in 3 minutes into recording. I'll go to 5 minutes and then I'll stop. Still equidistant swing. I think that is better to see without that other vertical laser. It does seem to, for you people with the video, it does seem to, it's alright for me, but you'll be watching this. Strong amplitude on our pendulum at the moment. And the indexing mark is pointing me at the moment. Alright, coming up to our 5 minute mark, what I'll do is I'll just give you a quick shot of that with my camera phone. Just illuminate that with a laser. And how you can see the indexing mark is swung around to me at the moment, which I'm not happy with. But we've still got plenty of amplitude with our pendulum. I'll give you a view from above. Following the laser exactly, I could say. Alright, I'll stop the camera now and we'll come back in 5 minutes. Still equidistance, come back in 5 minutes. And how you can see the indexing mark is swung around to me at the moment, which I'm not happy with. But we've still got plenty of amplitude with our pendulum. I'll give you a view from above. Following the laser exactly, I could say. Alright, here we are back again. The amplitude of the pendulum is starting to decrease a little bit, but I would say that's equidistance. I will give you a shot from the mobile phone camera. The amplitude is still significant. Our indexing indicator is still in that position. Switching our laser on. Following exactly the laser, which is indicated by the other camera. Still equidistance. Alright, we'll come back in... no, I don't think I'll come back. What I'll do is I'm pretty convinced this is still going in the... It's not being influenced by the Earth at any time. Oh, actually, no, what I'll do is I'll just let it die right to the end and I'll take a shot just at the end. And then I'll come back late at night when the sun has totally gone away, just to give you that reassurance that we're not being influenced by the sun. So I'll see you in probably maybe a good 20 minutes. Alright, it's 1936, so I can't wait any longer. It's not showing anything significant, so it's no use wasting your time. I'll give you a quick look with the mobile camera just as it dies. Slightly still swinging. I'll just illuminate that other laser. But it's exactly on the laser, nothing's moved. So what I'll do is I'll see you again later on tonight when the sun has definitely gone down. So here I go with my big long swing at 2000. I've increased the distance from here to here, which is another 300 millimeters. So I have a large swing. Here we go. Slight bit of tension on that bob as well, so it should swing. Oh no, it's corrected itself. maybe not. It's turning around towards me. Alright. Alright, I'm back here at 2000. The sun still hasn't gone down, so I thought I'd make the opportunity to have a super big large swing just in case something has changed. I don't like doing these big swings, but as I'll show you now. So here I go with my big long swing at 2000. I've increased the distance from here to here, which is another 300 millimeters. So I have a large swing. Here we go. Slight bit of tension on that bob as well, so it should swing. Oh no, it's corrected itself. Maybe not. It's turning around towards me. Alright. Okay, so there's a super long swing here. I'll give a measurement of that. That's 800 mil swing. I don't think the pendulum is isochronic, isosynchronous, or whatever it is, that word, which it will become unstable. I'll just put the other laser on. Okay, immediately went anti-clockwise by the looks of that. That should not have happened. It should have stayed equidistant for at least, I would say, 10 minutes. So that's what happens when a pendulum goes outside of isosynchronism. Immediately goes, I believe that went to an unstable state. I don't think there's any point taking more. We're outside the cosine equals 1 barrier. No, I'm not happy. Unless someone can come up with a reason. If a pendulum can go this far with an amplitude, I'm not happy. I'll just give you a shot with my mobile camera and then I'll stop it. So this would be a false experiment, would give people a wrong impression. Oh, hang on. Yeah, I'll give you a shot from above. Okay, it's going from right to left, right to left, right to left, right to left, anti-clockwise. Okay, that should not have happened at that early stage. I would say 10 minutes in, the Earth doesn't turn that quick. Which is mostly what you see on YouTube clips, this sort of instant. Alright, that's a false experiment, so ignore this. I'll go back to the 300mm, 320mm. Okay, see you next time around a bit later at night. Okay, it's going from right to left, right to left, right to left, right to left, anti-clockwise. So here we are at 2100, and we're about to launch for we're back to normal with our ratio of 7:1, just for our final, to prove that the pendulum is stable in that 7:1 ratio. Once again, the index indicator swings around and points at me. And we're about to launch for we're back to normal with our ratio of 7:1, just for our final, to prove that the pendulum is stable in that 7:1 ratio. Once again, the index indicator swings around and points at me. Seems to be swinging equidistance again. I'm almost 100% convinced now that operating within that correct ratio of 7:1 the pendulum is very stable and gives the exact same result every time, which in this case appears to be no deviation at all with the Earth. In other words, if we were to mechanically pump this for 3 or 4 days, I don't believe there'd be any change. Unfortunately, we can't mechanically pump it at this stage, which will be our next step, to add a mechanical assist. But as long as it operates within this 7:1 ratio, I'm 100% convinced that the pendulum will always be stable. Okay, 2 minutes in. I'll come back in a bit longer. I think we know what's going to happen. So I'll see you in about another 5 minutes. So here we are at 21:16, and the swing is equidistant. I'll just give you a shot of that with video. So the pendulum has still a fair bit of momentum there, and no doubt it'll be straight when we turn the laser on. Yeah, following the laser. Okay, I think we can safely conclude that if we operate within that 7:1 ratio, the pendulum operates very stable. And if we operate outside of that, I'm not quite sure how far out, but I think if we stayed 7:1 and we were to mechanically pump this pendulum for several days, I still believe there would be no change in detecting the Earth rotation. So maybe someone who's got better maths than me could give me some mathematical help with this, if you're prepared to come out. You know, I don't blame you, because this is quite controversial. And there's no doubt this would be considered a taboo experiment. So I don't blame you for keeping quiet. Okay, I think at this stage I'm 100% convinced that 7:1 ratio is a stable, and yep. Alright, we'll see you in probably, it may go to 12D if I can think of something else before we go to number 13 video. Okay, thanks for watching everyone, and we'll see you in the next video. So the pendulum has still a fair bit of momentum there. And no doubt it'll be straight when we turn the laser on. Yeah, following the laser. Alright, the summary is basically, as I predicted, was with that very large swing, our pendulum did go unstable and went in an counterclockwise direction. Interesting that the sun was on the west at the time. I wonder what would happen if the sun was on the east. But anyway, just did go clockwise. In that unstable, that's what I was saying. In this unstable prediction, maybe the sun could affect it. But while it's locked into its stable position and nothing. Anyway, think about that. Alright, definitely this one here was a big tick, green tick, red-green tick on that one. We're really happy with that. That launch indicator seemed like it never really affected anything, did it? So the swing was still accurate. Looked like the sun had no effect on a normal swing. Alright, so that's about it in summary. This was just, like I said, an intermediate video. I didn't really expect any big results, but okay, thanks for watching. We'll see you in possibly 12D.